The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to go on and take a look at section 9.5. Tonight's homework will be section 9.5 as well as the chapter review. Tomorrow, Wednesday, we will review for the chapter 9 test. And then on Thursday, there will be no regular class Zoom meeting. You will just take your test to be finished no later than Thursday night at 11:59 p.m. So there you have it, folks. All righty. So section 9.5 has to do with solving radical equations. Let's say we've got an equation that is as follows. The square root of the quantity x minus 10 equals 1. So we have an equation that contains one radical. Just like in solving absolute value equations, where there's just one absolute value term, we want to isolate that term. In this case, the radical term has already been isolated. What we're going to do now is we're going to square both sides of the equation. Squaring the square root gives us x minus 10, and on the right side, 1 squared is 1. So when we square a square root, it gets rid of the square root symbol. All right, now going on and solving for x, we'll add 10 to both sides of the equation. So we get x equals 11. When you solve an equation by raising both sides to a power or, both sides to a power, you need to check the solutions to make sure they work. Sometimes solutions that are called extraneous solutions are produced. These are solutions that once you check them, they don't work. So let's see what happens. If x is 11, we get the following. The square root of 11 minus 10 equals 1. 11 minus 10 is 1. The square root of 1 is 1. 1 equals 1. So x equals 11 is a correct solution. Let's take a look at another example. The square root of the quantity 5x minus 6 equals 2. Once again, we have a radical term, and it is isolated. So now we will square both sides of the equation. On the left side, we get 5x minus 6. On the right side, we get 4. Going on and solving the equation for x, we'll add 6 to both sides of the equation. 5x equals 10. Divide both sides of the equation by 5, x equals 2. Let's check our answer. So we get the square root of the quantity 5 times 2 minus 6 equals 2, which is the square root of 10 minus 6 equals 2, which is the square root of 4 equals 2, which is 2 equals 2. So x equals 2 is the solution. Notice over here we got the same, we got the solution equals the solution. That doesn't always work. In other words, that doesn't always happen. Go back to the last one. Here we got 1 equals 1, but the solution was 11. So don't confuse this with the solution. Okay, this is just showing that it checks both sides are equal when we plug the solution in. All right, let's take a look at another example. The square root of the quantity 1/2 x plus 3 equals 6. Again, we have one radical term, and again, it is already isolated. We'll square both sides of the equation to get 1/2 x plus 3 equals 36. That is 6 squared. Going on and solving for x, we'll subtract 3 from both sides of the equation. 1/2 x equals 33. Then we'll multiply both sides by 2. So x equals 66. Let's check our work. The square root of 1/2 times 66 plus 3 equals 6. 1/2 times 66 is 33. 33 plus 3 is 36. The square root of 36 is 6. So again, the solution checks. Okay, let's take a look at another example. And let's see, we have the square root of the quantity 2a minus 3, and then plus 3 equals a. So now the radical term is not isolated. So our first step is to isolate it. We'll do that by subtracting 3 from both sides of the equation, which gives us the square root of 2a minus 3 equals the quantity a minus 3. Now we're going to go back and square both sides. On the left side, we get 2a minus 3. On the right side, we get a minus 3 times a minus 3, which is a squared minus 3a minus 3a plus 9, a squared minus 6a plus 9. So foiling that, we get a squared minus 6a plus 9. So now we have a second degree equation. I'm going to put everything on the right side, set equal to 0 on the left side. So I'll subtract 2a and add 3 to both sides. I get 0 equals a squared minus 8a plus 12. Now, going back and factoring, we get a and a. How about minus 2 and minus 6? That would give us minus 8a in the middle and plus 12 at the end. So now we get a equals 2 and or a equals 6. Well, let's go back and let's check our work. Okay, I'm going to go to the next page and recopy that problem. We have the square root of 2a minus 3 plus 3 equals a. And we had a equals 2 and a equals 6. So a equals 2, a equals 6. So let's take a equals 2 and plug that in and see what we get. 2 times 2 minus 3 plus 3 equals 2. 4 minus 3 plus 3 equals 2. 1. Square root of 1 is 1. 1 plus 3 equals 2. 4 equals 2. Not true. So that solution would be called extraneous, and it's not, it doesn't work. Okay, let's take the a equals 6 and try that. Then we get the square root of 2 times 6 minus 3 plus 3 equals 2. Square root of 12 minus 3 plus 3 equals 2. The square root of 9 plus 3 equals 2. 3 plus 3 equals 2. 6 equals 2. Okay, I've done something wrong here. What did I do wrong? Hang on a second. I'm going to pause. I discovered what I did wrong right here. That should have been a 6 for this particular problem. So let's go back and fix this. Yeah, I plugged in the 2 from the previous checking of the work. Okay, so that one works. Sorry about that. Let's do another example. How about this one? The square root of negative x plus 2 equals x. The first thing I'm going to do, again, is to isolate the radical term. Then I'm going to square both sides. So on the left, I get negative x plus 2. On the right, I get, let's see, if I take x minus 2 times x minus 2, I get x squared minus 2x plus 4. Negative x plus 2 equals x squared minus 4x plus 4. It's a second degree equation. I'm going to add x to both sides and subtract 2 from both sides. So I get 0 equals x squared minus 3x plus 2. That factors into 0 equals x minus 2 and x minus 1. So I get x equals 2 and x equals 1 as possible solutions. Again, let's rewrite that, or I'm going to rewrite that, I guess. X plus 2, and then plus 2 equals x, and x equals 2, x equals 1. Let's see what works and what doesn't. If x is 2, we get the square root of -2 plus 2 plus 2 equals 2. Square root of 0 plus 2 equals 2. The square root of 0 is 0. 0 plus 2 is 2. 2 equals 2. So that solution works. If x is 1, let's see if I can do it right this time. We get -1 plus 2 equals 1. The square root of 1 plus 2 equals 1. 1 plus 2 equals 1. 3 equals 1. So that would be an extraneous solution. It doesn't work, but x equals 2 does work. Okay, let's take a look at another example here. Just a second. I want to make sure that I did continue the recording. Yes, I did. Just making sure. Okay. To solve each equation, write all proposed solutions, cross out those that are extraneous. We have the square root of 3x plus 5 equals 2. So again, we're going to isolate the radical term. So we'll subtract 5 from both sides of the equation, and we get the square root of 3x equals -3. Now, think back to the rules, the restrictions in this chapter. When you take an even root, well, you can't take an even root of a negative number. Also, when you do take an even root, you can't get a negative answer. That's what's happening right here. We're taking an even root and getting a negative answer. So already I can see that it's not going to work, but we're going to go on and find the possible solutions and then check them to see that they don't work. Okay, so now I'm going to square both sides, and I get 3x equals 9. Divide both sides by 3, x equals 3. Let's check our work. We get this, which is this. So no solution. And again, we could determine that way back here, but the way the textbook and I believe WebAssign is set up, they want you to find the extraneous solutions and then see if they do or don't work. Okay, let's take a look at this one. Now we're going to deal with a cube root instead of a square root. The cube root of 12m plus 4 equals 4. So again, the radical term is isolated, but now instead of squaring both sides, we're going to cube both sides of the equation. The cube of a cube root, the radicand comes outside. 4 cubed is 64. So we get that equation. Solving for m, we'll subtract 4. 12m equals 60. Divide by 12. M equals 5. So I get this cube root of 12 times 5 plus 4 equals 4. The cube root of 60 plus 4 equals 4. The cube root of 64 equals 4. Well, the cube root of 64 is 4, so 4 equals 4. It checks, and our solution, which I will write a little nicer, is m equals 5. All right, let's take a look at another one. We have, let's see here. How about this one? 2b plus 29 to the 1/3 power equals 3. Okay, so we're going to again cube both sides. A power raised to a power, you multiply the exponent, so the 1/3 power or the third root cube root, same thing. So that becomes to the 1 power. So we get 2b plus 29 equals 27. 3 cubed, 27. Subtract 29 from both sides. 2b equals -2. Divide by 2. b equals -1. Let's check our work. 2 times -1 plus 29 to the 1/3 power equals 3. -2 plus 29 to the 1/3 power equals 3. 27 to the 1/3 power equals 3. 27 to the 1/3 power is 3. 3 equals 3. So it checks. Okay, let's see here. Now, let's say we have a situation where we have two radicals. Just like absolute value equations, when we have two absolute value equations, we want to separate, or an equation with two absolute values, we want to separate the two absolute value terms. Same here, we're going to separate the radical terms, one on each side of the equation. They're both square roots, so we will square both sides of the equation. So we get m plus 4 equals 2m minus 5. Going on and solving for m, I'll do that and solve it on the right. Subtract m from both sides. 4 equals m minus 5. Add 5 to both sides. 9 equals m. Let's check our work. We would get, let's see, the square root of 9 plus 4 equals the square root of 2 times 9 minus 5. The square root of 13 equals the square root of 18 minus 5. The square root of 13 equals the square root of 13. Now, off the top of my head, I don't know what the square root of 13 is, but I do know that the square root of 13 equals the square root of 13. So this is true, and then the answer checks. Okay, let's see here. Now, yeah, let's take a look at this one. So we've got the square root of 12x plus 24 equals 6 square roots of x. Now, not everything is under the radical, but there are just two terms, one on each side of the equation, and they both contain a radical. But we need to be careful, because when we square both sides of the equation, on the left side, we're going to get 12x plus 24. But on the right side, we have a product, 6 times the square root of x, a product raised to a power. So we're going to attach that exponent to both of the factors. So what that ultimately gives us is 6 times, oh, not 6, rather 36 times x. 6 squared is 36. The square root of x squared is x. So we get 36x. Okay. I'm going to subtract 12x from both sides, giving me 24 equals 24x. I'm going to divide both sides by 24, giving me 1 equals x, or x equals 1. Plugging that back in to check my work, I get 12 times 1 plus 24, all under the radical, equals 6 times the square root of 1, which is 12 plus 24 equals 6 times 1, which is the square root of 36 equals 6, 6 equals 6, and it checks. But again, be careful. A common mistake is to just square that, but not square that. And then you get 6x where it should be 36x. So watch out for that. Now we're going to look at solving some formulas for a given variable. And we have d equals 1.4 times the square root of h. And we are to solve for h. Well, we've isolated the radical term, but there is a number out in front. It's still part of that term. We have a couple of choices. We can divide both sides by 1.4 first, or do it later. Let me show you both ways. If we leave it alone, the first thing we would do would be to square both sides. we would get d squared equals 1.4 squared, the square root of h squared, which is d squared equals, let's see, I believe that's 1.96, 1.4 squared, 1.96 h. So then we would come back and divide both sides by 1.96. So h equals d squared divided by 1.96. Well, let's go back and let's do it a different way. Let's divide by the 1.4 first. So now I've got d over 1.4 equals the square root of h. Squaring both sides, I get, d squared over 1.96 equals h. So it doesn't matter whether I divide by the 1.4 first or leave it on the right side to start with, but either way, don't forget you're going to square that number as well. Here's another example of a formula. D equals the cube root of 12v divided by pi. And we're going to solve this for v. V is locked up inside the radical, so I need to get rid of the radical. Since it's a cube root, we're going to cube both sides of the equation. We get d cubed equals 12v divided by pi. But I'm trying to solve for v, so next we'll multiply both sides by pi. So I get pi d cubed equals 12v. Then coming back and dividing by 12, we get pi d cubed over 12 equals v. So we solve for v. Let's see here. R equals the cube root of a divided by p minus 1, solve for p. Note that the minus 1 is outside of the radical. So the first thing I'm going to do is isolate the radical by adding 1 to both sides of the equation. Okay. Then I'm going to come back and cube both sides. So we get r plus 1 cubed equals a divided by p. We're trying to solve for p, and p is in the denominator. So I need to get it in the numerator. So I'll multiply both sides by p. But now I need to get p all by itself. So I'll divide by r plus 1, the quantity cubed. So p equals a divided by r plus 1, the quantity cubed. Okay, let's see here. Here is another case of an equation with two radical terms. They are already separated, one on each side of the equation. So I'm going to square both sides. On the left, I'm going to get 3 squared times the square root of x squared. On the right, I'm going to get the 3x plus 54. So back of the left, I'm going to get 9x equals 3x plus 54. Again, we're squaring the 3, and we're squaring the square root of x. We're squaring the 3 to give us 9. We're squaring the square root of x to get x. Okay. Subtract 3x from both sides. 6x equals 54. Divide both sides by 6. X equals 9. Let's check our work. Let's see. We get 3 times 3, which is 9, equals the square root of 27 plus 54, the square root of 81. 9 equals 9, and so it checks. Let's see here. That would be, let's take a look at this one. We have the square root of 22y plus 86 minus y equals 9. So we're going to isolate the radical by adding 9 to both sides of the equation. So the square root of 22y plus 86 equals y plus 9. Then we'll come back and square both sides. So 22y plus 86 equals y plus 9 times y plus 9. 22y plus 86 equals y squared plus 9y plus 9y plus 81. 22y plus 86 equals y squared plus 18y plus 81. It's a second degree equation, so we're going to put everything on the right side equal to 0 on the left. Subtract 22y and subtract 86. We get 0 equals y squared minus 4y minus 5. Factoring that, we get 0 equals, let's see, minus 5 and a plus 1. So then y minus 5 equals 0, y plus 1 equals 0. Add 5 to both sides, y equals 5. Subtract 1 from both sides, y equals -1. So we've got two potential solutions. Going to copy the problem on the next page and come back to check it again. Let's see, where did I get that one for right there? Okay, so we've got the square root of 22y plus 86 minus y equals 9. And y is 5 or -1. Y equals 5, y equals -1. So let's put 5 in for y. The square root of 22 times 5 plus 86 minus 5 equals 9. The square root of 110 plus 86 minus 5 equals 9. The square root of 196 minus 5 equals 9. 14 minus 5 equals 9. The square root of 196 is 14. 9 equals 9, and it checks. So this solution checks. Now let's try the -1. The square root of 22 times -1 plus 86 minus -1 equals 9. The square root of -22 plus 86 plus 1, subtracting a negative is like adding a positive, equals 9. The square root of, what is that, 63 plus 86 minus, no, it wouldn't be 63, it'd be 64. I like that number a little bit better. So then we get what? 8 plus 1 equals 9, 9 equals 9, and it turns out that both of these work. Let's see here. Where are we? Anyway, they both work. Okay. Let's see here. Oh, here we go. All right, this says, let S of t equal the square root of t plus h, and h of t equal, wait a minute. Sorry, wrong problem. Here, we can do this one. Okay, sorry. That other one leads to things that, yeah, we're not going there. So let f of x equal the fourth root of x plus 8 minus the fourth root of 2x. Now it says find all values of x for which f of x equals 0. All right, so what we're going to do, we're going to take the fact that f of x equals 0, and we're going to substitute that right here. So what that gives us is this equation. 0 equals the fourth root of the quantity x plus 8 minus the fourth root of 2x. Now we can come back and we can add the fourth root of 2x from both sides, or to both sides, and we get the following. The fourth root of 2x equals the fourth root of x plus 8. So because we have the whole thing set equal to 0, I can move one of the terms to the other side and have this situation. If you have 3 terms, 2 radicals and a third term, then things get way more complicated, which is what was going to happen in that previous problem, and we're not going to go there. So now I'm going to raise both sides to the 4th power, and I get 2x equals x plus 8. Subtract x, we get x equals 8. Let's check our work. 0 equals the fourth root of 8 plus 8 minus the fourth root of 2 times 8. 0 equals the fourth root of 16 minus the fourth root of 16. Well, the fourth root of 16 is 2, but even if it wasn't, the fourth root of 16 minus the fourth root of 16, those are going to cancel and get you 0. So x equals 8. All right, that's all I've got for you today. So again, a reminder, we're going to do section 9.5 tonight, as well as the chapter review. Tomorrow during class time, I'll review any questions that you have, and then on Thursday, you'll take your test. So have a great rest of the day, and we'll see you later.